Next up, our next speaker is Shran Moore, a platform architect at Anaplan. Shran's session is called Bring Your Own Key for SaaS. A bit about Shran. He manages architecture and strategy for the Anaplan platform, which includes data platform, APIs, workflows, integrations, identity and access management, and data security. Before his current role, he managed the product security organization. He's a strong believer in shifting security so that customers will enjoy better and more secure products. Please welcome to the stage, Shran Moore.
Good morning, good afternoon. Thank you for joining my session. My name is Shiran Mor. I'm, as you can hear by my accent, I'm originally from Israel, but I live in the Bay Area for the last 8 years. I'm a husband and a father of 3 little girls and also a dog. And during my daytime, I'm also an architect at Anaplan under the platform engineering organizations. And today I'm bringing to you Bring Your Own Key, BYOK for SaaS solutions. All right, let's get started. Is this talk is really for me? Should I be here and listen to me? Well, if you're considering implementing data encryption for your SaaS solution, you're in the right place. If you happen to use a third-party SaaS solution that offers data encryption, or you're just interested to learn about BYK because you heard this fancy buzzwords, so you're definitely in the right place. This talk is definitely for you. Let's get it going. So what we're going to talk today. So obviously, of course, we're going to talk about what is actually BYOK, Bring Your Own Key, and should you consider implement it. I'll walk you through some of the advantage and disadvantages while considering implementing BYOK. We'll do a quick kind of a TLDR of the common use case for using BYOK. Of course, I will walk you through about BYOK at Anaplan, and at the end, hopefully we'll have time for Q&A. During my presentation, I'm going to use a bunch of terminology from the encryption domain. I'm sure most of these terminologies you're familiar with, but in case we have folks here that are not or just new to this domain, I'll just quickly go over these terminologies. SaaS, software as a service, right? You run the software on your servers and not on your client servers. You operate everything, you manage everything from software perspective. Symmetric key, it's a single key that you use it's a digital key, of course, used to do the encryption and decryption operations. Asymmetric key is just a pair of keys. The public key is usually used for encryption and the private key is used for decryption. Ciphertext is the result of actually doing the encryption process on some clear text. So I have a text, I'm transforming to a text that is unreadable. HSM, hardware security module, that's actually a physical device that is managing the digital keys that you can create. KEG or key encryption key or master key, different places call it differently. It's the main key that is used either to generate more keys or protect the other keys. The other keys are the DEX, the data encryption keys. These are the keys that we use eventually to encrypt and decrypt our data. CSP, simple cloud service provider, or public clouds ones, AWS and others. And KMS, key manager service, that's actually a software base that manage the keys and the lifecycle, access control, audit, and a bunch of other controls needs to be implemented. So what is BYOK and should we consider implementing it? So let's start by just the use case, just to set the context for this conversation. Let's imagine that you're building, again, a SaaS solution, and that SaaS solution just, you can take it to wherever you want, but let's just focus on storing. You happen to store sensitive data. So you offer something for enterprise, and they need to store some of their sensitive data. So how do we protect that sensitive data? So the things that we quite often hear is that I'm applying encryption, so the data is protected. But when you say I'm applying encryption, we actually need to drill down a bit and understand what is you actually doing. So most cases, more common use cases, I would say, companies are just using the native encryption that the cloud offers. So in case of AWS, you just happen to use a key manager and you create some keys and you assign those keys into your storage. So this is good. This is good for when you're trying to, your requirement is protecting from the outside. Outside would be AWS employees that actually runs the data center wherever you are deployed. This is good. In case someone wants and come take a disk from storage, data is encrypted at rest. They can't have access to it. It's also protecting from certain employees. So not employees that don't have access to keys or to the key manager through IAM or through different access control mechanism, they cannot access. So you're really limiting the access to the keys, which also means you're limiting the access to the data only for really certain employees. Usually it's by your either SRE team, InfoSec team, really vary from company. This is all good. But what about inside threat, right? So as we can see in this module of just using simple native encryption, some of your employees do have access to the keys, meaning they do have a potential access to your customer data. Inside threat, why is it really a problem? So it is actually. It's truly a problem of real life scenarios, and some reports also show that actually the cost actually increased and the frequency of incidents increased almost in 50%. So it is truly a problem. Inside threats could be just negligent users, malicious users, or just stolen credentials, right? We hear about these cases all the time, mainly stolen credentials. It's probably the easiest one, but the other tools are completely irrelevant and real life scenarios. Consequences, I'm sure you guys can figure out kind of if someone gets access to data he's not supposed to. So things like loss of customers' trust, they will probably want to terminate their contract with you. You expose your customers also to some loss, depends on the type of data. They may put some risk, their users and so on. And just as a company, financial losses, fees, if you're a public company, share price cut, just reputations, no one's probably, everyone will think twice before they do business with you. So what do we do? How do we actually protect again from this small portion of users? BYOK is a really good option to mitigate that. So BYOK, bring your own key. It's the solution that allows your customers to bring their own key, to manage their own keys. And the keys that we're referring to, these are the DEX, the keys that are actually responsible to encrypt their data. Customer can import their keys, so they can generate and have a copy of their keys in their environment, import them securely into your environment. They manage the entire life cycle. They manage the entire access to the keys, who can have access and who should not have access. And as I mentioned, these keys are used actually to encrypt their own data. So they have full control over their data and if it's encrypted or not. Kind of the summary of what it really means to build such a platform. So the first thing is the obvious ones. You would need a key manager and HSM that supports such functionality. Not all key managers and HSMs as a combination supports a truly secure bring your own key, but most common ones do support them. You will likely need to build an access control around it. Given that the key manager is going to live in your infrastructure, you don't want to expose the key manager outside. Most key managers obviously come with implementation of access control, but it's not the same as your access control, and it's definitely not an interface you want to expose outside of your network. Hence, you will need to build access control around it. So you need also to make sure you apply correctly list privileges and segregation of duties to make sure that only customers have access to their keys. They prevent access from your employees, from your SRE team, so they have full ownership on their keys and their admins to manage the keys, manage the encryption. Audit is not per se part of implementing BYOK, but from compliance regulation standpoint, you do need to give a full audit record of everything that happens within the key manager. So you do want to expose and connect it to, probably you have your own audit system, and expose it to your customers. So customers do need to know and get a full audit trail of who accessed the key manager, of course, within their space, within their partition, who created keys, who ran encryption, and so on. So you want to consider that part of the implementation. And of course, you need also to build some custom way to do your backups of your data. So because now the data is encrypted with a customer managed key, and when you take the snapshot of the data, of course you can't decrypt it because that's managed by the customer. So you do need to build a system that actually combine backups of the data and the keys in case you need to restore. So you want to make sure you restore with the right keys as well. Let's move on. So shared responsibility, just like any other SaaS module, also here we have some shared responsibilities. Let's go one by one. The first one, it really depends if you have a private cloud or public cloud. In case you have a private cloud, then the entire HSM key manager management is up to you. You're the service provider here. You need to take care of purchasing, upgrades, and so on. It's completely up to you to manage it. If it's a public cloud, then it's managed, of course, by the cloud provider. They're responsible for the hardware in their data centers. You're managing the interfaces or the software piece of it. The key manager is same. If it's public or private, it's you managing it. If it's private, then hardware, you manage it. If it's public cloud, then the hardware piece of it, of course, managed by the CSP, but the key manager as a software, it's you managing it. Kegs, just remember the key encryption, the master keys, either it's managed by the cloud provider or by you, really vary from implementation to implementation. And the DEX, which is the critical piece, that's the data encryption keys. These keys are completely managed by customers and not by you or by the cloud provider. User management. So user management, there's two pieces of it. Usually there you have a system admin, SRE, someone from InfoSec. Again, very slightly if you're a private or public cloud. System admin is usually you. You need to manage the infrastructure. You need to manage tenants and bootstrapping some of the initial data that is required for BYOK. Key admin is just a terminology for who is managing the data encryption keys. It's the customer here. You don't get a chance to have that role assigned. It's part of your access control implementation that these kind of roles cannot be assigned to your employees and only to customer-facing users. Audit, you need to implement the audit and make sure you expose an interface that is with the right format. Ceph is the most common one, but you can, of course, expose more formats if it makes sense to your customers. Infrastructure, including backups, that's completely up to you. And again, if you're on public cloud, it's also on the cloud provider. You need to manage those backups of the data, encrypted data with the keys. All right. So how do we actually give customers an interface to import their keys in a secure way, right? So to use it, they use wrapping keys, the concept of wrapping keys, and I'll walk through kind of the summary of the steps that you would need to execute. You need to execute some of it. Your customers will need to execute some of them. Let's go one by one. So the very first step is a customer on their end, on their environment, they can generate keys. They can do that with on-prem HSMs, with cloud HSM. Either one work fine. They create the symmetric key. This is the deck, right? So the deck that will be used eventually to encrypt their data. So that's the first step. The second step is that's where you need to expose an interface. Let's generate symmetric key. Asymmetric key, excuse me. Asymmetric keys, again, a combination of public and private key. Private key remains in your infrastructure. You need to definitely give an API to return back the public key. They need the public key in order to wrap it, encrypt their private key so they can import it securely. So using your public key, they will wrap their private key, just like we see in the envelope. So they can import over to you a key that is encrypted. So your applications, your network cannot even if they want to, they cannot even see the key material, their private key. And once the key is there on your side, in your key manager and HSM, you can then unwrap it, but then the unwrapping happens inside your key manager HSM, and then you don't have exposure to that key. So then that key gets imported into their partition. All these operations can be done, again, vary from system to system. Most commonly just talking with HSM directly using PKS 11, for example, to do the wrapping functionality on their end. And in the end state, customer created their own key. They imported the key securely into your environment, which from that point, at the very last step, step 8, they can, again, depends on your implementation, use this key, or by key alias, of course, not by the key material, to encrypt my data. How do we deal with key rotation? So depends on which key. If it's the keg, the master key, then as I said, that's your responsibility to make sure you're rotating it by your company policy completely. And ideally, that should be built in your key manager solution that you picked. And the deck, so from deck perspective, it's not really a key rotation. It's more accurate to say rekey. Rekey means that I'm just using a new key for new data, but I can also do transformation of existing encrypted data with the new key. That's going to be completely on the customer responsibility and based on the customer policy. What is the cadence they want to do it? Some customers may ask to do it every 6 months, 1 year. It really depends on them. They control it. You can help them by giving them, exposing them notifications. Hey, your key is about to expire. But it's completely up to them to manage the life cycle. Let's talk about some environment considerations that you want to think about. So if you're running on private versus public cloud, depends which environment you have. On private cloud, it can be quite heavy from operational standpoint. As I mentioned, you need to manage all the hardware of Key Manager and HSM. You need to have the right folks for that. It can be costly dollar-wise to do it as well. Again, depends on which vendor you decide to work with. But it's really the truly only option that gives you full control over your HSM. With other options on the public cloud, the underlying hardware is still managed by AWS, for example. You may share, you probably likely also to share the physical hardware behind the scene, and you're just getting a partition part of it. So you don't have a truly ownership on the entire stack. Where on the private cloud, it's only you there, right? Only you use the HSM. But public cloud, just like any other services, it's just easy to spin up, right? One click of a button, you get yourself a combination of Key Manager and Cloud HSM that you can manage. Single tenant versus multi-tenant, again, depends on your solution. With single tenant, from access control perspective, things get to be more easier to implement. You less need to think about how do I make sure that I don't cross the boundaries between tenants. With multi-tenant, of course, that gets more complicated. You need to implement slightly more controls to make sure that you do the partition correctly and make sure you do the access control correctly and the audit records are not mixing up between tenants and so on. So kind of the normal things you need to think between multi-tenant. Just when it deals with access control on keys, you need to work slightly. You need to implement slightly more things. Encryption consideration. So another factor that can impact which kind of a vendor solution you want to pick will be also where do you want to apply encryption. So where can I apply encryption? So I can use native encryption. Native encryption, most of you, I'm sure you're familiar with on the public cloud. When you create a bucket or you create a folder or whatever that storage is, a database, RDS, on provisioning time, you specify a key to use the encryption. It's nice, it's easy, it's fast. It gives you good security, as I mentioned, from the outside. And can also be from inside in case that key was imported. But have in mind that if someone has access to the storage, they can see the data because the data is only encrypted at the disk level. So once S3 actually pulling the data from the disk, inside S3 it's actually decrypted. So whoever gets access to your S3 bucket, then they can see the data. Sometimes it's really fulfilling the requirements. Sometimes it isn't. Depends on your implementation. Transparent encryption, stronger encryption. Keys are accessed only by a middleware layer, a service, an agent. Again, it's vary from implementation to implementation, but the concept is that applications don't really talk directly to storage. They talk through some middleware. The application will submit a clear text to the middleware, and the middleware, before it's actually transmit or forward the data into, let's say, S3, it's doing the encryption. So the only component that needs access to the keys is that middleware or agent. Depends on the implementation. That component needs access to the keys and encrypt the data, and then data is encrypted in S3. So the data is encrypted both on the disk and also in S3, meaning when you try to access S3, you don't see a clear text. If you access directly, you just see a cipher text. You see encrypted data. And to pull the data, also the agent pulls the data on behalf of the application, runs the decryption, and then gives back a clear text to the application. So why is it good? It's good because you decoupled your encryption from your application, which is really good if usually it's being implemented by two different teams. And from access standpoint, the access control is now defined in that middleware, part of that agent policy. So the policy to the agent say, to get that access to the data, which pretty much also means access to the keys, only this application is allowed to. So a human being cannot actually interfere in the middle. And then you have another layer, because your application also, that's where you need to build your access control correctly, because then applications prevent from anyone that is not authorized to read the data. So you apply access control in both layers, and then you segregate and separate between the different layers. You get a stronger security posture. And the last one is application encryption. That's actually quite expensive, although it's considered almost the most secure way to encrypt your data, because the data never leaves the application unencrypted, compared to the native encryption, where when the data leaves the application unencrypted, here the data leaves the application completely encrypted. So it's more secure, but it's complex to implement. It's complex to implement because then if more applications need access to the data, you may need to also share the keys or access to the keys to more applications. It can get complex if you're trying to apply it on an existing infrastructure or platform where multiple applications access the same storage. So you may want to strongly consider if you really need to have that kind of level of encryption. Usually most cases are good enough or not good enough, are perfectly suited with transparent encryption. But in case you need to, that's also an option. Other considerations that you need to have in mind before you're implementing is, do you really have interest by your customers, right? So it's also kind of related to my second point. Your customers also need to be kind of techie enough to consume it, right? They need to understand the concepts of encryption and BYOK, and especially if you only expose the secure way of wrapping keys to import their keys, they need to have the right infrastructure on their end. They need to know how to talk to HSM, know these PKS 11. So you strongly need to consider that if your customers have the ability to consume it. If they don't have the ability to consume it, why even bothering? On your end, you need to have the right experience and the resources to implement it. So you need to have people with the right background, the knowledge how to operate Key Manager and HSM, especially if it's in your private data centers. These are strongly points to think about before you enter this journey. Quick comment about the differences. Sometimes people tend to confuse between these three things. BYOK is what we're talking about. It's the ability to bring your own data encryption keys into environment. BYOE, bring your own encryption. That's usually when you, as a SaaS solution, brings your own HSM into the environment. So all the encryption process actually happens within your HSM and not with, for example, a cloud HSM. And hold your own key. This is actually when all the encryption operations actually happen on their customer side. So they encrypt the data, they manage the keys on their end. They do the encryption on their end, and then they just import completely encrypted keys. So they hold everything on their end, and they don't delegate anything to you. Quickly on the advantages and disadvantages of BYOK, we kind of went over it just to quickly summarize the things that I mentioned. So the biggest advantage is you just give a stronger security posture. Data is protected both from outside AWS and both from inside from your employees end to end. You give customers more confidence in your platform whenever it's always in the SaaS environment, whenever things are self-service, full control by the customer, that's where they have more confidence in your platform. And then you can also fulfill some other requirements like regulations and compliance if you have customers that require Bring Your Own Key in order for them to use SaaS. That's going to give you a big advantage in the market. And you also, from your perspective, you're going to reduce some of the burden to manage the life cycle of the data encryption keys, which otherwise you will need to deal with policy of rotation, three keys, and so on. Disadvantages, I mentioned, it's quite expensive. I'll summarize it this way. As I said, you need to have the right folks with the right experience and knowledge, and the maintenance of it, especially if you guys are running in private data center, it's quite expensive to deal with the hardware and the maintenance of the operating system and just the software piece of it. Backups, it's quite complex. And as I mentioned, depends on the vendor. It can be quite costly money-wise. And as you can understand, the implementation can be complex as well. Just quickly summarizing the use cases. Again, the very first thing is just give more confidence to your customers to use your platform. As I mentioned, everywhere you can give their control, they will be more happy. If you need to store sensitive data of your customers, you definitely want to consider implementing BYOK. If you're working with regulated customers like governments, banks, and so on, they will probably going to require you to have a BYOK in order to do business with you. So that is a big factor. And then from your perspective, if you want to have controls over your keys in your AWS, then you definitely want to consider BYOK. All right, let's talk about what do we do at Anaplan with BYOK. So just one word about Anaplan. So Anaplan is a SaaS solution of connected planning. Planning as a business-wise, you can, most common one is a financial planning. Of course, this one is easier to understand, but you can definitely do planning across your organizations in your marketing and HR and even engineering. You can do your planning and forecasting in our platform. And the connected planning is the interesting part where you actually connect the dots from all your departments. So as the office of CFO can get a joint of the numbers of forecasts from all its departments and the actuals and the forecasts and make better decisions out there. To work about our platforms, our platform is a multi-tenant, multi and hybrid cloud. We run on both on AWS, GCP, and private data center at the same time. So just one big platform span across all these clouds. And we use file system to store our customer data. So and you can imagine customers bring very sensitive data into Anaplan. This data is stored eventually on file system. So how do we protect the data that they bring in on the disk? So we implemented BYOK. We support AES-256 symmetric keys for our customers to encrypt their own data. We give our customers 3 ways to bring their own key. The reason we actually give the first 2, we generate for them a key or we allow them to import key, because we understand that now customers are techy enough or really have HSM on their end to do the wrapping, or they just don't necessarily want to deal with PKS11 protocol to actually do the wrapping. So we give them the ability to tell us to generate for them a unique key. They can, if they wanna, they're familiar with the couple open libraries to generate symmetric keys, they can do that, and then they can import kind of a hexa of the key into our, but we definitely recommend and we give tutorials and guides step by step how to use the wrapping key functionality. They can also do rekey with us. So when they have a key that expired, they don't want to longer use it, and they want to transform data that was encrypted by that key with a new key. We give them a rekey. We at the behind the scene, we don't really decrypt everything and encrypt everything. That's gonna put their data. That's gonna potentially at risk, even if it's likely for a couple of seconds. Instead, we do transformation byte by byte. So at any given point of time, their data is encrypted, and sometimes while we're running this rekey operation, the data is encrypted with the old key and some of it with the new key. Pretty fast operation. But what's important is that their data is always encrypted. And so what do we really offer them? We offer them FIPS level 140-2 level 3 key manager. We run our own key manager and HSM in our private data centers. We do that by using transparent encryption as well. And everything is using a kernel module that we install in every of our machines. So all the encryption, decryption, and access control is actually applied on the kernel space and not on the user space, which also kind of don't allow us an opportunity even to try to bypass any access control. We implemented full separation of duties, so really no single admin can do everything. There needs a combination of admins to do something. As I mentioned, we provision our own system admin, and they provision their own key admins. They get full control over their encryption and key management. We also give residency because we're a multi-region, so keys don't leave region. We only store them in region. We definitely take backups, but the backups are encrypted as well. And compliance reporting, we give them full audit trail of success and failures events. Thank you so much for listening. I hope you enjoyed it, and enjoy the rest of the conference.
Thank you so much. Hi, Shran, and welcome back, Puneet.
Hi.
How are you?
Good. Thank you.
Good. I have a couple questions here. So, which key manager vendors do you recommend?
So I'll say it really depends. It depends on your needs. It depends on your requirements. It depends on your budget. They're the most common ones that, if you even Google it, will be Thales, Hashi, and new ones in the market, which pretty good, Achilles and Fortnix. I would recommend you to do a comparison based on your requirements. Again, based on all the considerations that I mentioned, and pick your best option.
Puneet, anything you want to add to that?
I think Shirin covered everything, and I think those are the best in the breed options which are available in the data security space.
Thank you. Which HSM should I use? Start with you.
Yeah. So again, depends where you run and your budget. If you're in the private cloud, there are quite a few companies that do sell HSM. Again, like Thales, they sell their own HSM, but there are others. I do recommend to check out the NIST website to certified companies that sell HSM. If you're on the cloud, again, you also have options there. You can use obviously cloud HSM, but there are companies that do offer managed HSM, which is probably the first option you should look on. If security is not your core business, I do recommend looking for managed services. As you saw, it's complex to manage this piece of infrastructure.
Puneet, anything to add?
Sure. So as Shirin mentioned, basically there are a lot of vendors which are out there, and the HSMs which you normally use for the encryption are the general purpose HSM, and all the vendors which are out there which provide this general purpose HSM, they expose same kind of APIs such as PKCS11, JCE, CAPI, CNG, and the GEL. So again, as Shirin mentioned, depending on your use case, you need to do a proper mapping of your requirements with the HSM vendor, and do look basically for the NIST and the FIPS certifications of them and what NIST and FIPS are recommending, and then go with that.
Yep.
And then I have another question here. Which encryption method do you recommend with BYOK?
Yeah.
So I think this is again depends on your application and your platform and how is it designed. As I mentioned during the talk, there is some complexity of implementing either one of the options. Um, I recommend using again the transparent encryption that I walked through. Most of those known vendors do support this transparent encryption. It's stronger. It's much stronger than just using the native encryption, definitely. And it's not complex as doing application encryption. So although application encryption gives you the strongest way to secure your data, but you should strongly consider if you really need that. If there's a specific requirement that actually said the data cannot leave memory unencrypted, then you may want to consider it. As I mentioned, it's complex. You need to give access to many services. If more services needs access to the data, you need to have embed your libraries of doing those SDK to encrypt inside application, inside your core business, which is not something you want from software development perspective. You do want to decouple between those two things. And if you think about decoupling design, then you end up with what we call transparent encryption. Hence, I would recommend starting with looking into that. But again, based on your design, you may come to a conclusion that you can't do it, or you actually have to do application encryption, for example.
Okay. Thank you. Puneet, anything else you want to summarize from this session? That's the last question I have here, but if there's anything you wanted to add.
No, I think Shirin has covered everything. So yeah.
Well, thank you very much, both of you, for joining
Okay.
us live. And Sharon, thank you for your presentation.
Thank you. Thank you for having me. All right. Enjoy,
Thank
everyone.
you, guys. Yep.
All right.